vast landscapes of time, strewn across millennia, archaeologists have unearthed countless artifacts that whisper tales of our ancient past. Among the most intriguing of these are the handstones, dual-sided stone tools, often with a pointed tip and an oval shape. They first appear in the archaeological record around 1.4 million years ago, remaining a common element for over 1 million years. But what makes these handstones so prevalent in our archaeological records? What mysteries do they hold? Handstones have been associated with a variety of hominids, including Homo ergaster, Homo erectus, and Homo heidelbergensis. Thousands of these handstones have been excavated from sites across Africa, Europe, and Asia, and have been the subject of intense scientific research. Despite this comprehensive study, 5 fundamental questions remain unanswered. Why are handstones so common in the archaeological record? Why are they often found in such large numbers at individual sites? Why was time invested in creating these tools when simpler tools or even simple flakes would have served the same purpose? What was the benefit of incorporating a high level of symmetry in so many handstones? And how can we explain the oddities, especially the giant handstones? These questions lead us to interesting theories. One such theory is the idea of sexual selection. This theory suggests that individuals with attractive traits are chosen as mates, and if these traits have a genetic basis, they will proliferate in subsequent generations. In the context of handstones, this could mean that these symmetric tools were particularly attractive to the opposite sex due to a developed perceptual inclination towards symmetry. Symmetry is found in the morphology of living things as single genes control the development of features on both sides of an organism. As a result, the level of symmetry is a good indicator of an individual's physical and genetic health. However, there is a fundamental difference between handstones and other indicators of good genes. Handstones are not attached to the body and therefore to genetics. Without effective countermeasures, an individual could avoid the costs of producing a handstone by acquiring a high-quality one through theft or collection. This could explain why handstones are often found in such large numbers at individual sites, with many appearing unused. Our theory posits that the observation of the production process by a potential mate is the deciding factor, explaining why handstones were discarded shortly after their production. Handstones were products of sexual selection. They served as reliable indicators of the quality of a potential mate. Symmetrical handstones pointed to good genes with a high level of physical and intellectual fitness. The cost that the producer took on was itself an indicator of fitness. Furthermore, handstones exploited the perceptual inclinations of the hominid's developed psychology. As a result, cultural traditions of handstone production thrived during the Pleistocene. Between the emergence of large and complex societies and the significant change in gender relations resulting from women's increased dependence on men's support. In summary, handstones, these seemingly simple stone tools, hold a wealth of information about our ancient past. They are not just tools, but symbols of social dynamics, indicators of health and fitness, and products of cultural evolution. They are relics from a time when our ancestors were beginning to shape the world around them, just as they were being shaped by it. These handstones, silent and unchanging, are a testament to the complexity and depth of our shared human history.